Hey everyone, this is Jim Leonard, and I thought I'd make kind of an unconventional video. This is a video for true computer nerds of the 1980s. This is a niche video, excuse me, where I patch a game to work on the IBM PCjr. Already, you know if you want to see this video or not. So if you don't, then now's the time to stop. But if you do want to see it, let me explain what I'm going to be doing and why. In the 1980s, IBM came out with a machine called the IBM PCjr, and this was a machine that was supposed to be their attempt at a home computer. Unfortunately, in their effort to keep costs down and add new features, the PCjr was not 100% compatible with the PC. It was very close, but a couple of things, especially with integrating with the graphics, were different. And as a result, unfortunately, there are quite a few games made in the 1980s, well, actually, throughout the entire life of the PC, throughout the DOS and the booter era, that don't run correctly on a PCjr. And most of these are actually, it's possible to patch these games so that they work correctly on a PCjr. And I recently did that with Elite, the very famous space sim shooting action trade routes, do whatever you want, open world game. And it was interesting enough that I thought it would be worth going through here. So we're going to do this completely with tools that you already have on a PCjr. This is going to be the same way that people used to do things back in the day, which is to say that they didn't use fancy disassemblers or IDA or Turbo Debugger, although you can use Turbo Debugger on a PCjr if you have enough RAM. We're just going to use debug. So this is for quick and trivial hacks only. This is not necessarily for something super complicated. You can also use this procedure to remove copy protection, but I am not going to cover that specifically in this video. Maybe a future one. What we're going to do is fix Elite. Now, in order to figure out what's wrong with Elite, let me show you a still of what Elite looks like running unmodified on the PCjr. You should see it right now. And you'll notice that the display is garbled, and that is because the PCjr's video hardware was not completely 100% compatible with IBM CGA. And some programs, in an effort to speed things up, would directly bit bang the ports to do things like change the palette or whatever. The way you're supposed to do this, excuse my phone here. The way you're supposed to do this is using BIOS calls, but BIOS calls are slow. So some programmers did this manually. Well, the manual stuff breaks. So let's come back to the DOS session here. We are going to search for writes to the video hardware. And then, because that actually doesn't fix the problem, I'm going to show you what else we can do that actually, I'll illustrate what I actually did. So here we go. First thing to do, if you want to use debug to patch an executable, first you have to make sure that the executable is not compressed. There's a wonderful program called UNP by Ben Castrium, I think that's how you pronounce it. And what we're going to do is run it on the line-drawn version of Elite. And, Ben Castricum. This is a wonderful utility. Most executables prior to 1989 were not compressed, or if they were packed with something called exe pack, and you can still patch those pretty well. Later, 1989 and later, you'll see a lot of executables that were compressed with either LZEXE or PK Lite or something. You want to make sure you're working on something uncompressed. So our game is already uncompressed because it was made in '85. And now we're just going to use whatever's on the system, and debug is on the system. However, you can't, normally to load a program into debug, you would run debug and then the actual name of the program, like you see here. But if you load an exe program in debug, it relocates segments, and you don't want that if you're just simply trying to patch something in place. So what we're going to do is a little trick. We're going to copy, excuse my horrible typing, to something else. I'm going to call it Elite Junior, and we're going to name it bin, either bin or com. Well, actually not com. If you name it to com, then only the first 64K will load. If you name it to bin, it will load linearly in memory, which is what we want. So by copying it to a binary file and then running debug on the binary file, we get the whole thing in debug. Now, debug is used for a couple of things. It's used to you can single step through a program. In fact, here, if you do question mark, you'll get a list of all of the commands that you can do. Debug may have come with DOS 1.0. I don't know that offhand. I didn't research it before starting this video. I know it comes with 2.0 and later. It's a standard part of DOS. So you can do this even if you have just a plain Jane PCjr and DOS 2 disks. You can do stuff you can do in debug includes assembling instructions. You can actually write a program from scratch in debug if you want to. You can do things like compare RAM. You can dump RAM. You can. There's my phone again. I am going. Forgive me. I'm going to make sure my phone stops making ridiculous noises. That's better. And you can go to a specific part of the program and execute from there. You can manually send bytes out to ports. It's a really great low-level interface to working with the system. We're going to use it for a couple of things. Now, the first thing when patching a PCjr program, if it's doing something really crazy or stupid with the graphics hardware, that is usually messing around with ports 3D8 and 3D9. And it's not, I'm not going to go into exactly what those ports are used for in CGA, but suffice it to say they're used for things like changing timing. They're used for setting, the whole range of ports is used for setting the background color, the palette, what mode you're in, etc. You can search the binary file that you've loaded using S. However, I am not an amazing assembler programmer. I don't have every single assembler opcode memorized. So what I like to do, when I'll demonstrate. When you load a program into debug that is a binary file or a COM file, it doesn't actually load it right at the beginning of the next available segment. It loads it like a COM file would at offset 100 hex. And you can see that if I tell debug to just simply unassemble, which means to disassemble or to show you what it's loaded. If I just hit U for unassemble and hit enter, you can see it starts displaying from 100 onward. That is because, and I may be misstating this, I believe the first 100 hex or the first FF hex bytes are the program segment prefix, I think. If we're not using that space, so we can actually, it's not part of the file that's loaded, we can actually use it as scratch right now because we're not actually going to try to run this program. We're just simply patching something in RAM. So let's look at one common thing. If you wanted to disable custom writes to CGA hardware, you would look for anything that is trying to output to port, let's say 3D9. Now, I don't actually know right offhand what the opcodes are, but you can use this scratch space at the very beginning at 0 to do some quick assembles and then actually look at what the data is. So A for assemble, start making a new program at offset 0 of the current segment. And the common way to output stuff would be something like move DX and then 3D9, because you can only output to high range ports by using DX. And then you want to look for out DX comma AL. So let's look at what those look like. So for the first two, whoops, sorry, I'm telling it to unassemble from offset 2 and then show me like unassemble the first 4 bytes. Okay, so move DX looks like BA D903, and out DXAL looks like EE. That's in the second column. So now we're going to try to find this in the program. So let's search from 100 onward to FFFF. Now this is only going to search just the beginning segment. I happen to know that Elite, even though it's roughly 70 or 80K, all of the data is at the end of the executable. So it's okay to search just the first 64K because in this case, Elite, the program code actually does fit in the first 64. So we're going to search from offset 100 to offset FFFF, and we're going to look specifically for somebody setting up a port write to 3D9. So let's look for BA D903. It's going to search and it finds a couple of things. Let us go ahead and unassemble around that area. If I actually unassemble the very specific locations that it gave me, let's unassemble at 4B08, we see, oh look, there it is. There's move DX 3D09. And then, okay, and then OR, so then it does something to whatever the value is in AL. I could look up, I'm going to go ahead and look up a little further. Let's start unassembling from a little bit earlier, like 4B00. All right, so it moves a value into AX and then into memory somewhere. Okay, so here we go. At 4B06, very specifically, it moves 4 into AL. It sets up the port write to 3D9. It sets a bit in AL. I don't know why it just didn't do that when it moved the value in, and then it outputs it. Typically, port writes to 3D8 and 3D9 are unsupported by the PCjr, and it's a toss-up as to what happens when you write to them. I believe most of them are discarded, if not all of them, but just to be safe, let's say that this type of thing is causing trouble. To disable it, you can just simply turn the actual out instruction into a no-op instruction. So that means it would do nothing. So very specifically, we can see the out at 4BOD. Sorry, let me just tell it to unassemble. Oops. Okay, let's unassemble. I just wanted to unassemble a couple of bytes here. All right, forget it. Let's just do 4BOD. Okay, well, there it is at the top of the listing. So EE out. So to disable this, you can then you can enter, and then you tell it where, 4BOD, and then it will start showing you the previous byte, and you can then enter the new byte. And I want it to be 90. I happen to know 90 is no-op. I can understand. I'll show you in the listing that that's what it is. Hitting enter will stop it. Now, an interesting thing about the enter command, if you want to keep going. Now you notice I said enter. Go ahead and enter data at that location. You'll see it's now changed to 90. If you hit spacebar, it will leave it alone and it will keep going. So I can then change any of these variables that I want. I'm hitting space to skip right now, and I can hit enter when I'm done. So let's go ahead and unassemble 4BOD again. I'm trying to give it a small. I don't know why it's not working. I'm trying to give it a small range so that I don't have to show you the whole darn thing. But now you'll see that it's changed to a no-op. So now, if we wanted to write this out and save our changes, you can do just W. The default size, when something is loaded as a binary file, the number of sectors to write, I believe, is pre-populated in CX. And if I hit R to display registers, I can see that CX is 7B70. So if I hit write, that number is automatically correct, and there it goes. It kept track of. It looks like BX has some of it, and it looks like BX CX. It looks like that is the size of the file. So it noticed it. It wrote it out. And then normally you would quit, you'd be done, and then you could copy it. You could copy it or rename it. So you'd want to rename this, to exe, and you'd be done. Now, that's basic patching with debug. That's looking for a certain instruction and changing things on the fly. That is not actually what I did with Elite. Elite was a very specific case in where I went ahead and did all that, and yet it would still glitch up the display. It was important to note how it was glitching up the display. The display was actually fine when the game ran, but then as soon as you hit a key to go from the main screen to the titles to the credits screen, it glitched up. You could then keep going, hit a key, and it would start up in text mode. You could launch out into the system, and then as soon as you hit a key and fired a laser, suddenly the screen would glitch up again. It only happened when you hit a key. So I had to look through the whole program to determine if it was the hitting the key part or something else. And what I actually found, and we're going to go ahead and go back into debug here to the binary file. What I actually found was that when hitting a key and making a noise were things that happened simultaneously at the time of the glitch. And I looked for all of the keystroke hitting code, and I looked for all the sound code. And it turns out that, in fact, I'm going to go ahead and search for it right now to show you. It turns out that whenever Elite tried to mess with the speaker, the speaker port actually contains a lot of stuff in it. I'll put up a quick text diagram here. The ports on the original PC, the first 2 bits control the speaker. The second bit, so bits 0 and 1 control how the speaker operates at port 61. The second bit is reserved. It's undefined. And then the others are things like memory refresh and or memory enable rather, and well, you can see it in the chart here. I'm not looking at the chart now, but I'll put it in the video, so you should be staring at a chart here. And you're supposed to leave all of that alone and only modify the first 2 bits for the speaker. Now, take a look at this chart, which I'm going to put up next to the other one for the PCjr. And you'll see that they're quite different. The first 2 bits do control the speaker, but the second bit is a controller. It's a video controller hardware bit to determine whether or not the system should be in either text or graphics mode. And it turns out that Elite was setting that bit when it should have been cleared. Setting the bit, you'll see in the chart, says text. Clearing that bit means graphics. So what I did this time is I loaded up Elite into debug, and then I started searching for everything that output to the speaker. Now again, I don't have everything memorized, so I'm going to remind myself what outputting to the speaker is. Actually, here, let's start assembling. Okay. Actually, I don't want to assemble right in my space. I want to assemble at that scratch area. We're never going to actually be running this code, so it's okay to muck with the scratch area here at the beginning. Let's see. So let's see what out 61 AL looks like. This is how you put a value in AL and you can output directly to the speaker. Sorry, everything is always... Okay, so another important lesson with debug, everything is automatically hex. So you always type in hex when you work in debug. So 61 is not 61 decimal, it's 61 hex. Okay, so what does that look like? Okay. And out 61AL looks like E661. So now let's search the first segment of the loaded code for E661. And it helps if you type it correctly, E661. And there we go, lots of stuff. Let's start with the first one. What does 223 look like? Okay, well, it's an out, but that's not enough information for me. So what I did was I went up a little higher. Let's start unassembling from earlier up. And that's actually, I started at the wrong byte. So I started in the middle of an instruction. Debug is unfortunately not smart enough to fix, to unassemble from a logical place, and I told it, I want you to unassemble from 200, damn it, no matter what it looks like. Now, the first 2 lines you're seeing, the in AL CD, that's sort of nonsensical on this platform, and push SS is also kind of nonsensical. There's almost no reason why you would actually want to push the stack segment. So I'm going to move forward a little bit. I did it from 200. Let's move forward from 200. Let's try unassembling from 201. That's much better. Looks like an interrupt 16 jumping somewhere and then returning. So if we look down a little bit in this unassembly, we see some timer stuff happening. And then this is what caught my eye, and I'm going to center right in on it on 219. Here's where it is typical when a program outputs the speaker, when they're going to do something very specific to it, it is typical to read the contents of port 61. Remember how 61 controls more than the speaker. It controls some pretty important stuff in the system, and if you send the wrong bits to places, it could affect the system pretty badly. It is typical to read the current value, store it somewhere, and then you always have that. You can restore that value, changing only the speaker bits, and then sending it back out. That way you know you're only changing the stuff that needs to be changed, and you have a record of what it was before you started. So in the first line, we see in AL61, that's tell me everything that's in port 61, and then move that to a certain location, which it does. Then the next line is AND that value with FC. And FC looks like that's hex. Binary looks like this. Okay, that's what FC looks like. And you'll notice that bits 0 and 1 on the end here are thrown away, and then the rest are kept. What this is a very typical way of shutting off the speaker. So what the code looks like it's doing is it is saving the contents of 61, saving it in a variable, then setting it for speaker off, and then saving that in a different variable. You'll notice it's moved 2008 instead of the first place. Throughout, sure enough, I'm not going to do it now, but if we search the whole program for outputting to the speaker, you can see it retrieving this value from 2008 constantly, and then mucking around with the sound, with the speaker bits, and then sending it out to the port that controls the speaker. Now, that is extremely typical. And remember I said that the bits 0 and 1 control the speaker, but it's this bit here, it's bit 2 that is undefined on the PC. On PCjr, it holds the state of graphics mode. So when this program first starts up on a PCjr, it starts up at this particular location in text mode, and it saves that bit in text mode. Later on, when it tries to change the sound in the game, it is throwing this information back out, but the game is running in graphics mode. So when you tell part of the system that you're in text mode, while the other part of the system thinks it's in graphics mode, you get this graphical corruption. The fix for this is thankfully pretty easy. On the PCjr, on bit 2, if that bit is clear, then it means graphics mode. And the speaker, the Elite only outputs sound to the speaker in graphics mode. So this was thankfully a very easy fix. What we're going to do is change how it creates the speaker off variable, and instead of and ALFC, which is perfectly valid for a PC, we're going to change it to 8, F8. I'm going to stop that. Now F8 looks like this, and you'll notice there's one extra bit clear. So F8 hex is this in binary. And by storing it with the bit already cleared that specifies graphics on PCjr, when you now run it on the PCjr, we'll go ahead and save this. So you would patch that. Let's go ahead and unassemble it again just to check. Okay, and the code looks good. We'll write that. We'll quit. We will rename our binary file to exe so we can run it again. And now when you run it, you have a perfectly uncorrupted display. So that's it. A little long. Sorry for the lack of editing and a bit of rambling, but this is very typical. This is how I used to crack games in the 80s because I didn't know any better. The cool kids, the people who are much better at cracking games than I, started out with much better tools. They would either use Turbo Debugger. They had a 386. I didn't have a 386 until 1990. And not only that, they used some of the best crackers that I know for this particular vintage hobby. Use something like Soft Ice, which lets you set hardware breakpoints on certain interrupts or certain memory reads. Very powerful tools. And nowadays, actually, you can do some pretty amazing debugging using an emulator. DOSBox, for example, has an emulation mode where while a particular game is running, you can hit a keystroke and then go into this nice debugger. It's not quite as nice as some other tools I've used, But because it's an emulator, you can do quite literally whatever you want. You can tell it breakpoint here. You can tell it stop execution if this memory location is modified, or stop execution if this interrupt is fired, such as, for example, a copy protection disk interrupt, like interrupt 13. So really great tools. But I thought it would be kind of fun to see how we used to do this in the 1980s with only debug.com. So I hope that was useful. If you'd like any videos for this kind of thing, any sort of very low-level vintage PC hacking, or anything low-level PCjr or something like that, feel free to leave me a comment. And I read all the comments for all my videos, for better or for worse. Hope you enjoyed it. Thanks again.